All right, as you can see, we're moving further into these. When we get to numbers 3, 4, and 5, we now have it back in expanded form for the function that they give us. And we are going to need to remember that factors of c that add up to b process to get to factored form first before we solve. So let's take a look at those. So first things first, remember, so value of a is 1. So I see that b equals 6 and c equals 9. So I have factors of c that add up to b. So that means numbers that multiply to get 9 that add up to 6. Hopefully you're beginning to see it, but at this point I still have my 1 times 9, 3 times 3, ends up being 3 times 3. That's the way that it would go. Now, I'm going to show a little bit of a shortcut here. Some of you may see this, some of you may not. So if I can go back and connect you to something when we did on part A, if you look up here, notice how as soon as we did that 6 times 4 for A1, notice how when we plug those to split these two, it ended up being exactly the same things that went into our final factored form. It is a bit of a shortcut. It isn't always easy, but it is a way that we can work through that. So I'm going to begin to work under that kind of shortcut now on some of these, not all of them, but some of them for sure. So in this case now, what I can see is that because it's going to be 3 times 3, I can automatically go like this, x and x, and then plus 3 and plus 3. Now, if you're not sure about that, you can go back and check that to make sure you use that area model, see if it actually works. But it does, in fact, work, and it saves a little bit of some time and some steps. So now I'm going to go right into here. 0 equals 3, or x plus 3. Oops, should drop the parentheses. And 0 equals x plus 3. Well, in this case, I'm going to do my minus 3 and my minus 3 canceled. I'm going to have 0 minus 3 is negative 3. And the equals x. Same thing over here. Minus 3 and minus 3. It's going to be gone. Negative 3 equals x. So in this case, we only have one answer. X equals negative 3. And that means if we made that graph, that the graph would be like at the very, very bottom part of that graph. Like it'd actually be the main point. We'll talk more about that in future lessons. All right, number 4. I have x to the second minus 16. Okay, sorry, that's going to squeeze in there. All right, here we go. Now we don't have a b, or do we? A is still going to be 1. So what we're going to be looking at here is figuring what the other parts are. So what is the value of b in this case? Well, is there a b? Yes, there is. Value of b equals 0. Because remember, 0 times that x would make it disappear. So then c equals negative 16. So factors of c that add up to b. Well, what numbers multiplied times themselves get us negative 16 but will add up to 0? Well, factors of 16, I'm going to have a negative 1 times 16, a negative 2 times 8, negative 4 times 4. Hey, look at that. See right there? That's what we would have in this case. And that's going to be a bit of a shortcut. We're going to find these patterns will work when we have the missing b or as a 0. It ends up being a quick, perfect square that we work with. So it's going to be 0 is equal to x minus 4 and x plus 4. So when I drop those parentheses, I'm going to have x minus 4 here and 0 equals x plus 4 here. So plus 4 on both sides. I'm going to get 4 equals x. Same thing over here, minus 4 here, minus 4 here. It's going to be gone. X equals negative 4. So my two answers are x equals positive 4 or x equals negative 4. Both of those cases would give us the roots or the zeros. Number 5. Okay, so I have this one. 0 equals x to the second plus 10x plus 16. All right, 0 equals x to the second plus 10x plus 16. All right, again, a equals 1. So we're going to go right in. Factors of c that add up to b. Well, b equals 10, c equals 16. All right, so think about numbers here that multiply to get 16, but add up to 10. I know it's going to be a 2 times 8 in that case. That's what I'll do this setup here. So I'm going to divide that out and go straight into my setup. So if x is going to be plus 2, and x is going to be plus 8. So 0 equals x plus 2 and 0 equals x plus 8. Minus 2 on both sides, minus 8 on both sides. Negative 2 equals x, and negative 8 equals x. So my values would be x equals negative 2 or x equals negative 8. All right, number 6. Now we're changing the game a little bit. We no longer have our value of a is 1. The value of a in this case is 2. So it changes our work. Remember, we're going to need to do a times c to figure out what's going to go there. So I wrote that here. I got the little shadow there. Sorry about that. Let me move this up some. So value of a is equal to 2, b equals 7, c equals 6. Remember, we have to do a times c. That's going to equal 12. So factors of 12 that add up to 7. So my 1 times 12, 2 times 6, 3 times 4. Oh, look at that, 3 times 4. Now in this case, I don't do the area model. In this case, what I do is I need to divide this guy into 2 parts. So what I'm going to do is I'm going to have this be a 2x squared. I'm going to make this plus 3x plus 4x plus 6. Zoom that in some here. Sorry about that shadow, guys. It's in a really bad spot. Oh, you guys still see it? Okay. So remember what we did is we actually went in and we made 2 new binomials with that. And so we would draw parentheses around all of this and then begin to work to factor those. Now remember, because these are 2 things that have something in common with greatest common factor, we could factor that out. So between the 2 and the 3, nothing is going to be there other than 1, so we don't worry about that. But if an x squared and an x, I can factor out an x. So I'm going to factor out an x and do that division. So 2x to the second divided by x. That would end up leaving me, so 2x to the second divided by x. I would end up having a 2x. Same thing over here, 3x divided by x. I'm going to basically have a plus 3. Remember, the goal is to have the exact same thing on the inside. So over here, when I come to a 4x plus 6, what can I factor out of both of those? I can factor out a 2. That's a greatest common factor. So I would do a plus 2 coming out. So 4x divided by 2 is going to give me a 2x. So far, so good. And then I'm going to also have a chance to do a 6 divided by 2, which is going to be plus 3. And that matches up perfectly. So it turns out what I actually would have is this. I would have the 2 things on the inside, so 2x plus 3. And I have this on the inside. I'm going to have an x plus 2. So what I do is I take that set up there and I make both of those equal to 0. So let me do that over here where there's a little bit more space. So I'm going to have 0 equals 2x plus 3 and x plus 2. So my 2 things, I drop the parentheses. So 0 equals 2x plus 3, and I have 0 equals x plus 2. Minus 3 here, minus 3 here. Going to cancel. This is going to be negative 3 equals 2x. Divide both sides by 2. I'm going to have x is equal to negative 3 over 2, and that's one of them. Over here, same process. Minus 2 on both sides. I'm going to have negative 2 equals x. And so those are my 2 solutions. I have x equals negative 3 over 2, or x equals negative 2. All right, B7. How can you check your solution without using a table or a graph? Well, this kind of goes back to what we just did up here on problem 3, explain how the solutions relate to the graph. What we would do is we'd go back and plug in those values for all of these answers. So we don't have to do that. What we could do is for B1, plug negative 1 and negative 7 over 2 in for this function, and that would work. Or we can plug in 5 and 2 into this function, and it would work. Or negative 3 in here, and it would work. Or 4, negative 4, or negative 2 and negative 8, or negative 3 over 2 and negative 2. All those cases we would get 0, and that's how we would know our answer is correct. All right, on to part C. It says here, solve each equation for x without making a table or a graph. Check your answers. Okay, so now if you look back at these are not the same setups of the equations as we saw in part A and B. These are gonna have the 3 parts or the value of C is 0. In each of these, this is gonna go back to an either working with the way that it is, or doing some reverse distributive property where we look to factor something out like we did in these guys here. These are going to all have the value of C be 0. So it changes the work that we need to do. So let's take a look at that. So whenever they're already in factored form, though, we don't have to do anything more. We just begin to work with that. So C1, we get 0 equals x times 9 minus x. Well, right away, we just begin to separate that out. And so this is just something to make sure you're aware. We don't need to distribute this through. We begin to just pull those apart like we saw before. So one of them we already have right there. X equals 0. That's part of it. The other one we have x equals 9 minus x. So since this one's done, we don't worry about it all. But over here, I'm going to move that x. So plus x here, plus x here. It's going to be canceled. 0 plus x is x equals 9. So my answers are going to be 0, x equals 0, or x equals 9. Now they did give us specific directions to check, and I know sometimes you don't want to do that. We're going to do that anyway. So in this case, what I need to do is first of all okay, so x equals 0. So I would do y equals, I'm going to put that here, I'm going to put my 0 in this case, so 0 times 9 minus 0. Well, if I do that work in here first, I'm going to have 0 times 9, which would give me a y equals 0. So that one checks. Then over here, I do the exact same thing where x equals 9. So if I do that here, y equals, I'm going to plug it all for each of those x's there. So 9 times 9 minus 9. So we do that work inside here first. 9 minus 9 would be 0. 9 times that, y equals 0. So that checks as well. That's how we would find out that solving. All right, moving on to C2. So we now have 0 equals negative 3x times 2x plus 5. Okay, so again, we don't need to do the distributive property through. We just work with what we have right now. So I would have 0 equals negative 3x and 0 equals 2x plus 5. Okay, so in this case, I need to divide that by negative 3, divide by negative 3, divide by negative 3. X is equal to 0, right? That's going to be that one. I have a little bit more work to do here. So minus 5 here on both sides. This is going to be a negative 5 equals 2x. Divide by 2, divide by 2. X would equal negative 5 over 2, or that also would equal negative 2.5. So the answers would be x equals 0 or x equals negative 5 over 2. So when it comes to checking that, let's do that here. So if I plug 0 in for the first one where x equals 0, I would have y is equal to negative 3 times 0, all that times 2 times 0 plus 5. Well, this would be 2 times 0 is 0, plus 5 is going to give me a 5 in here. Then I've got negative 3 times 0 is going to be 0 times 5, so you can see y would equal 0. That checks. My other option is going to be here to take the value of a negative 5 over 2. So I'm going to plug that in here. I'm going to come down a little bit further. So y equals negative 5 over 2. So, oh no, sorry, x equals that. So y equals, I'm going to do my negative 3 times negative 5 over 2. All that times 2 times negative 5 over 2 plus 5. All right, so remember this like having a 1 underneath it. There's no cross canceling here in this case, but I would have negative 3 times negative 5 is going to be a positive 15 over 2. Then in this case, I would have, excuse me, I would have this be like over 1. So you can see what happens here. I've got these guys can cancel. So it's going to end up being a negative 5 plus 5. That would be 0. So I'm multiplying all of this times 0. And anything times 0 we know is 0, so y equals 0. So that checks as well.